The lab this week is about plate tectonics. It's a simulation basically that has also includes some videos, some interactive tutorials. And at the end of the lab, there is also a website where you have a quiz that you need to, that have questions, and basically you need to complete those questions, multiple choice questions. So let me go to the lab here. If we go to week number 13, and we'll click on experiment number 13, plate tectonics. You'll see two documents. There is a procedure document and there is the report sheet document. If you click on the report sheet, that's the part basically you need to submit. The assessment of this lab is lab report. It's not multiple choice quiz, okay? There will be, as I mentioned, there is a quiz, but it's in the form of website. So this, in addition to the report, there will be a quiz at the end. So make sure, of course, to answer all the questions using red font. Okay, all answers should be in red font. You can use blue if you want, but make sure not to use black font. And then, so at the end of the lab report, there is this link here. If you click on it, it will open a website. And this website has questions. Okay, so you need to answer those questions. And after you answer those questions, it will give you your grade. Okay, and you can do it more than once. You can do it twice, 3 times, as many times as you need. Okay, but basically it will give you a grade. Now don't copy and paste the link of that grade. You need to take a screenshot. Okay, one of the common mistakes in previous classes, the students copy and paste the website. Don't copy and paste the website. I will not be able to open it. So just take a screenshot of the grade you got, 60%, 70%, 90%, whatever grade you got. Okay, make sure to take a screenshot of it, and then after you take the screenshot, you'll just attach it here. Attach your screenshot here that shows you the grade. If you're able to score 90% or higher, you'll get 2 extra credit. But you need to do it, of course. This is a mandatory question. Even, I mean, if you got 50% or 60%, you still have to paste the screenshot. This question worth 5 points. Okay, it's worth 5 points with the possibility of getting 2 points extra if you got 90% or. But yeah, make sure to put the screenshot there. So those questions, you'll answer them based on the procedure. So this is the lab report. We know the lab report is based on the procedure part. So make sure you download the procedure. This is the link, and you'll download the procedure. Okay, enable editing. And it has the link to the simulation. You'll make sure you'll press Control and then left click on the link here to open. And this will open plate tectonics. You can always go to the PhET website and write and type plate tectonics. Okay, guys, now, as I mentioned, you need 2 things. You need a computer that has Windows. And then the second thing, you need to JavaScript. You need to have JavaScript on your computer. Or to update your JavaScript, just type java.com. Okay, it will open the website that has Java, and you can click download Java. Now it's very simple. The process is very simple. I showed you a video over that. Here I'm using Chrome. So you click here on download. Okay, it will start downloading. Click keep. Make sure you click keep. And then, yeah, here it's downloading. So you can either show in folder or open whenever it's done. Just make sure you access this file. So it's saving the file here. You can click open here or show in folder. If I click here on show in folder, it will show it in the folder, download folder. Click on it and it will open. Okay, just make sure you follow this procedure. If you have Windows and you update the JavaScript, you should not have problem downloading the simulation. Okay, unless your computer does not save certain files that is downloaded. But this is the simulation basically. You'll start with the crust tab here. You see here oceanic crust, continental crust. You can zoom in or zoom out as needed. You can view density, temperature, both. Show labels. You can measure the density. It will ask you, I think, to measure the density here of the oceanic crust. And now when you when you want to measure the density of something, make sure that this indicator here, this needle is touching this thing. So for example, if it asks you to measure the density of the ocean, you'll place it in the ocean. If it asks you to measure the density of the oceanic crust is this light gray area. Okay, so make sure the needle is touching this light gray area. Okay, the same thing, you look at the density of the oceanic crust, you'll compare to the density of the continental crust. So you can move here the gauge and measure the density of the continental crust and see whether the reading will be more or less. It will enable you to compare readings. You don't get values here, but it will enable you to compare the value of the density, whether it will decrease or increase. Also, for example, you place it here in the crust in between the continental and the oceanic, and you can vary the temperature and see how the temperature affects the density. For example, if you increase the temperature here, what will happen? If you decrease the temperature, what will happen to the density? So you can play with the temperature. Also the composition here, if you drag the slider to the left, you'll be increasing the content of the iron in the crust. While if you move the slider to the right, you'll be increasing the silica content of the crust. So again, you can check whether the density will increase or decrease if you increase the iron. And the same thing for the silica. You can see the difference here between silica and iron, and even the change in the color of the crust. Also, you'll check the effect on the thickness. If you increase the thickness of the crust while decreasing the thick. And of course here, when you decrease the thickness, be careful guys. So you need to make sure that the needle is still touching this light gray area. So you might need to raise it a little bit here so that it will still be in contact with this gray area, light gray area. So yeah, when you take it all the way thin, it's still touching there, still in contact. So you can play with that here in the crust tab here. Then you can go to the plate motion tab area here. You click on plate motion, okay? And you can use, for example, if you want continental crust here, you can take continental crust and just drop it. This area will become continental crust. If you want oceanic crust, either young or old, you can drag it and place it there. Okay, so now you have continental crust and old oceanic crust here. And you can see what happens when the plates move. So for example, if you want to move the plates toward each other, you'll click on the green arrow here, and you can see the plates are sliding under each other, and you can see the effect here creating, volcanoes. You can see volcanoes are being created here. Okay, and it will tell you the time elapsed, like 50 million years here. You can again measure temperature, use the temperature here, the density, take here and measure temperature. You can here take the density and measure the density and so on. Even you can measure the thickness here if you want to measure the thickness. You see here the edge here is in kilometer, it's 0 kilometer. This is 20 kilometer, 40, 60, 80 kilometer, and so on. So you can measure the length if needed. Then you can reset all here. If you click reset all, everything will be reset. You can use, for example, young oceanic crust here versus old oceanic crust if you want. So now we have 2 plates. One of them is old oceanic, the other one is young oceanic. And you can create any type of motion. You can use converging motion or transformational motion. If you click here on the blue one, you can see now they're moving parallel to each other. Okay, and you can see what type of phenomena will happen there, how many years it will take, reset it all, and you can do the whole thing again. So make sure to follow the procedure, answer the questions. If you look at the procedure part here, there are several also. So this is the link to the website. There are also other links especially when you start the part over plate tectonics. The first 3 links are tutorials, interactive tutorials, and the 4th one is a video, YouTube video, that will help you understand the concepts, okay? And this will prepare you for next week lesson. Lesson number 24 is over geology. So those are important links to prepare you for that. Make sure to work on those tutorials, answer the question from the simulation. Those tutorials will give you the conceptual understanding. And then at the end, yeah, this link worth 5 points. Again, if for whatever reason you cannot access a computer that has Windows, you have 2 choices. You can do the extra credit assignments that I mentioned in the announcement that I emailed you 1 week ago, or you can do the research paper. There is the choice of writing a paper to make up for a lab, and the instructions are in the last 2 pages of the syllabus. If you go to the last 2 pages of the syllabus, you'll see the guideline for writing a paper. That's if you don't want to do extra credit, you want to save the extra credit for extra credit. But of course, the best thing is to do the lab. I gave you materials per lab were available from the beginning of the semester, so you know that this lab require Windows. So you just need to find a computer that has Windows and has Java. JavaScript should be updated on it, and you'll be able to do it. And I have, guys, computer that is 15 years old. My other computer here is Toshiba, is 15 years old, and I was able to do the simulation fine. So the simulation, you should not have any problem with the simulation if you have Windows. All type of Windows should work with this simulation. Just Mac does not work. That's the only problem, Mac. Okay, and it's Java-based. It's Java-based, so you need to download Java. All right.